Hello everybody, welcome to the course of Occupational Ergonomics and Work Disability Prevention. My name is Talia Al-Nabi and it's a great pleasure for me to teach you Occupational Ergonomics in this fall semester. Actually, my background is medicine. I used to be a sports physician and I was working with professional athletes and elite sport teams for about 15 years. My expertise has been mostly prevention, management, and diagnosis and management of musculoskeletal problems. I then decided to pursue an academic path. I entered in a PhD program at the University of Montreal, and my thesis was about the rehabilitation of shoulder injuries, especially rotator cuff problems. I then continued my studies on shoulder pathology as a postdoctoral fellow at the University of Waterloo. It was a great opportunity for me not only to continue my studies on shoulder problems in a shoulder evaluation laboratory at that university, but also to face with different ergonomics questions and fields. This course is an introductory course and we try to build fundamental knowledge in occupational ergonomics. So for developing these skills in ergonomics, you need more studies and also more experience in field. I hope after finishing this course you understand the terminology in ergonomics and also the mechanisms of work-related injuries. I try to teach you how to assess the work-related injuries in workplaces, and also I will introduce you different legislated guidelines. These are the topics that will be covered during this course. So you can see that we have 5 to 6 topics in the first half of the course, and then you have your midterm exam. Then you will have another 5 to 6 topics, and then your final exam is not a cumulative type of exam. I will ask you the questions that are related to the materials of the second half of the course. For each course, I may upload a presentation. The presentation can be by myself or by Dr. Nicolas Ladelfa. I may also upload the other presentations which I find interesting from the other universities. And I may ask you to read 1 or 2 chapters of your reference textbook. And it's possible that I upload some other reading materials such as journal articles or the chapters of other textbooks for you. So this is your evaluation method. 40% of your grade is related to your midterm exam. The other 40% is related to your final exam. You also have an assignment that includes 20% of your grade, and the due date for your assignment is November 10th, 2019. So what is your assignment? I want that you choose a job. The job can be from any categories. Childcare workers, office workers, healthcare workers, factory workers. It doesn't matter which category you choose. But I want that you describe the job and you describe what the physical, mental, and organizational demands for that job are. And also I want that you explain that any risk factors related to the job that may cause injuries. Also, I want that you elaborate on preventive strategies, and also if you can find any legislative guidelines related to that job. Your assignment should be at least 10 pages, and at least you should use 5 references for this assignment. The main textbook for this course is Production Ergonomics, and you can easily download the PDF format of this book by the link that I provided for you. I also uploaded the book on your Blackboard. For each class, I may also post other related articles or even chapters from the other textbooks, and I really expect that you look at the materials that I provide for you. This is my email address. Please feel free to contact me if you have any question or concern, or even if you have any comment or suggestion regarding the topics. You are very welcome. Okay, I hope the course structure is clear for everybody now. So let me start with an introduction to occupational ergonomics. What is ergonomics? Actually, the word is coming from a Greek root. So ergon means work and nomos means natural laws. So ergonomics actually means the science of work, and the focus of the science is human body and human work. Ergonomics is not as old as medicine or even industry. The discipline of ergonomics arose from a special social situation during the Second World War. You know that during the Second World War, many of able-bodied men participated in war. So the industries faced a need to adapt the workplaces with the new workforce. So when many people were in war, they needed vehicles, equipments, services. So a new type of industry developed at that time. So in this type of industry, they had to produce products at high pace with high quality, and therefore they required more manpower. So to fill the demand, they had to retrain and transfer male workers from other businesses to the warfare industry, and also call on the women, the elderly, the disabled population, and also the previously excluded social groups such as prisoners. So as a result of this diversification of working population, industries began to invest in physical aids, machineries, tools, in order to help weaker workers to carry on the assembly job. And even after the war, many of these groups remained in employment. Therefore, most focus in science of ergonomics was understanding the capabilities of different working population, as well as understanding the workplace demands and job demands, and how to fit the job demands with the physical capabilities of working population. This type of ergonomics is called physical ergonomics, and as you can see, the focus in physical ergonomics is on human body, body posture, health and safety, and perceptual capabilities of human body, and how these factors can affect the design of technology. Since 1960, we have the development in technology, in computer science, and also in robotics. So the other area of ergonomics came into consideration, which we call it cognitive ergonomics. In this field, the demand of technology on humans were highlighted, and the focus of cognitive ergonomics is cognitive psychology, mental workloads, skills, cognitive limitations, and other psychological aspects of the human and their effects on work. For example, you can imagine how much stress can be applied to a person who is working as an air traffic controller. So the question of ergonomics here is how much rest that person may need, and how this stress can affect the decision making, how often that person should go for a break, or the questions like that. Since 1980, the researchers realized that it's not just the design of ergonomics that can affect the changes in workplaces. They realized the great impact of interpersonal relationships on ergonomics outcomes. So in this respect, we can say that it's not just the ergonomists and the people who are directly involved with the changes in workplaces, the safety of the workplaces, that can influence the improvement in workplaces. but all the organizations or the systems, the goals of the systems, and the people who are involved in decision making, they may play or they will play a very important role in ergonomics. These people include engineers, economists, managers, operators, and all the people who are somehow involved in decision makings and somehow involved in changes in the workplaces. So we can see that the economic and organizational side of ergonomics took more attention little by little. And in 2000, International Ergonomics Association decided to strengthen the industrial relevance of ergonomics by declaring that ergonomics is not only focused on humans' well-being, but also on the efficacy, performance, and productivity of work systems and machines. In this view, the occupational ergonomics can create a win-win situation for both the organizations and the workers. So when by the science of occupational ergonomics, we can optimize the workers' well-being. At the same time, we can optimize the productivity in the system as well. And if we minimize the workplace stress factors and minimize the injuries and the injury risks, so we at the same time minimize the compensation costs. All of these can increase the profit for different organizations. Therefore, I can say the best definition for ergonomics is what released by International Ergonomics Association in 2000. And in this definition, both aspects of ergonomics, I mean the optimizing human well-being and also optimizing system performance were mentioned. You can see for achieving these two important goals, I mean optimizing the human performance and optimizing the system performance, a multidisciplinary team is needed. And this multidisciplinary team can be include people from different backgrounds, but all of them are somehow involved in decision making and changes in workplaces. These people may include engineers, managers, operators, as well as the people who are directly involved with the health of workers, such as the physicians, physios, and occupational therapists. Okay, after reviewing a little bit about the definition of ergonomics and the history of ergonomics, I want to focus mostly on the injuries. You know, most of the injuries in the workplaces are related to musculoskeletal system, and we call them work-related musculoskeletal disorders, or WMSD. You will hear this abbreviation a lot during this course. Many of workers, they have very minimal type of symptoms such as pain, discomfort, and fatigue, and they can continue their work despite these symptoms. However, these symptoms may affect their productivity, their precision, and the level of work that they are doing. When the limit passes from what a human body can tolerate, then we have more severe symptoms such as loss of function, limited movement, limited in range of motion or in muscle power. So the worker needs to leave the workplace and rest and rehabilitate. So to evaluate the severity of the injuries, sick leave is one of the important factors. There are different types of WMSDs. Most of WMSDs are acute injuries. Acute injuries can be secondary to fall, being hit by a heavy object, or the body reaction to slipping, to tripping. And we have the injuries such as fractures, lacerations, sprain, strain in this category. The other type of WMSDs are chronic injuries. Chronic injuries are usually secondary to repetitive motion disorders, or they can caused by incorrect posture, muscle fatigue, friction due to an awkward motion, compression of a tissue, or overexertion. Most of the chronic injuries can be secondary to a cumulative type of trauma. What I mean by cumulative type of or cumulative trauma disorder, imagine that you have an injury in a tendon or in a ligament. The injury, imagine it's a minor trauma or it's a micro trauma. So when we have injury in a ligament or in a tissue, so we have an inflammatory reaction. We have swelling, we have built up waste products, we have a little bit decrease in oxygenation, inflammation response, and so on, and the patient may feel pain. If in the early stage that we have symptom, we have an intervention, we may give some time to the injured tissue to be healed. But imagine that we don't have any intervention at the early stages. So without early intervention and with repetitive irritation, I mean that the worker still continues the work in the same awkward postures or with the same type of compression or exertion. So actually the tissues don't have enough time to be repaired. And in this situation, a cumulative process will begin, and a treatable mild trauma may change and become a chronic type of injury. There are different risk factors for WMSDs, especially for chronic type of WMSDs. We categorize these risk factors to external factors and internal factors. External factors are the factors that are related to the work condition and also the environment. And most of these risk factors are actually modifiable. So, for example, the work that need a lot of repetition or forceful exertions or awkward posture or vibration, they are the situation that may predispose the person to different type of, especially chronic type of injuries. The policy of the system or the organization, especially the policy of the recovery time can also affect the type of chronic injuries. On the other side, we have internal factors. Internal factors are the factors that are related to the workers themselves, and mostly they are related to the conditioning and lifestyle of the patients or the workers. So, for example, we have studies showing that the people who are physically fit are actually 8 times less predisposed to work-related injuries. Or we have studies showing that people with higher BMI or the people who have diabetes, they may have some kind of chronic work-related injuries. Smoking can affect the healing of the tissues. So if a person has an injury and the person is a smoker, so there is more possibility that the healing of the injured tissue be deteriorated. And also the attitude of the person, the personality, the stressfulness of the person, all may affect the predisposition to work-related injuries. It's important that you recognize these risk factors, and it's very important that you understand that which one of these risk factors can be somehow modified. In future, we will talk a little bit more about the prevention strategies and how we can somehow modify different risk factors in the workplaces. Look at the different work condition and you can find risk factors easily. For example, on the left side, you can see the man with the arms in overhead posture, and he may need to keep this posture for a long time. And so you can see the awkward postures into other workers bending and changing the posture with rotation of the body. So these people may be more predisposed to back injury, for example, or that worker in your right side who is working in a poultry industry. You can see that repetitive type of motion, and because of the height of the worker, you can see that the posture of the upper limb may be different from, for example, the other workers, which is beside that lady, and you can see that she needs to do a repetitive motion with the arm in the shoulder height, which this type of movement may somehow predispose the person to some kind of chronic shoulder or neck injuries. So the occupational ergonomics actually tries to somehow minimize these risk factors and somehow to modify these risk factors and control the adverse effect of working in those conditions. If you want to know how big the problem is, you should look at the epidemiological studies and statistics. For example, in Europe, WMSDs are the causes of half of the sick leaves, and they cost 240 billion euro per year. And most of the permanent incapacities in this continent are due to WMSDs. Also, you can see that 44 million workers in Europe may have WMSDs, and interestingly, 30% of them may have depression. This depression can be secondary to their injuries, or the depression can be secondary to other socio-economical situation. But anyway, depression can affect their treatment, and also depression can affect their work productivity in future, even when they back to work. By far, back pain is the most common WMSD all over the world. This graph shows different injuries based on the body parts, and you can see that trunk, back, and upper extremities are the most common sites for work-related injuries. I should mention that work injuries may be different based on different works and based on different areas. So it's important, if you are working with a group of workers, it's very important that you know about that specific epidemiology of injury related to that specific work. This report is related to the workplace injury in America in 2011, and you can see that again back injuries are more common, 30% of the recorded injuries, then shoulder and then knee. And if you look at the causes of injuries, you can see that 22% of the injuries caused by overexertion. This graph shows you the cost of injuries based on their causes, and you can see that also the number of acute injuries are higher and the total cost may be higher, but you can see chronic injuries are really costly. For example, in the first column you can see the injuries that happened secondary to overexertion, and you can see that the number of payment and the amount of payment for these injuries compared to other type of injuries. Also, even the injuries that happened by repetitive motion, also the number is not, the percentage of those injuries may not be very high, but again there is $2 billion cost for the injuries which are a type of chronic injuries. You can see the same scenario in 2019. Although we have a little bit less percentage of the report related to overexertions, but again overexertions are the main cause of the injuries in workplaces. Now, this graph was very interesting to me, and I wanted to show it to you too. So you know, although the number of back injuries are much higher than the other part of the body, but you can see that the injuries in the upper limbs, especially in wrist and shoulder, need more days away from work than the other part of the body. So it means that those injuries are not as common as back injuries, but they may be more costly. Okay, let's see what is the situation in Ontario. You can find the statistics for work-related injuries in WSIB website or wsibstatistics.ca. So as you can see, the claims were mostly for acute injuries. 47% of the injuries were sprain or strain, and we have 17% of injury secondary to overexertion. And as you can see in the last graph, and the graph in your right side, the most common part of the body which will be injured by work-related causes is low back. Looking at this table, by looking at this table, we can have more detailed information about the nature of injuries in Ontario. For example, for me, it was interesting to see that most of the leading age group are middle-aged people. And, you know, workforce aging is one of the hot topics in ergonomics. And there are a lot of research and studies running in different universities and centers about the capabilities and improvement the workplace places for the aging population. You can see that some of the injuries, for example, low back injuries and shoulder injuries are caused by overexertion, while the injuries of the lower limb are mostly acute type of injuries. You can also see that some injuries are more common in female, and it's interesting for me that the injuries in cranial area, such as concussion, are more common in female based on this report. So by understanding different trend and different type of injuries, you may be able to understand which problems should be targeted and how we can implement a preventive strategy. If you want to have a good preventive strategy in a workplace, it's very important that you know the epidemiology of the injuries for that worker in that workplace. At the same time, you need to have a very good understanding of biomechanical considerations and physiological considerations, especially the one that are related to the neuromusculoskeletal system. So I recommend you to review chapters 2 and 3 of your textbook. I won't ask you about the materials during the midterm or final exam, but they are very important for your understanding of the other concepts that will be discussed later on. Let's review an example of how we can use basic science in occupational biomechanics. You know how forces are distributed within a material. We have different type of materials. Some of the materials have elasticity. So it means that that object can resume its normal shape after being stretched or compressed. Some other materials may have plasticity. It means that they deform without rupture by action of force, and they may remain deformed even when we remove the force. And we have viscosity, especially for liquid type of materials, or liquid or gas, the fluid type of materials, I mean. So viscosity means how much resistance that material has against flowing or against movement. For example, honey has a lot of viscosity and water has less viscosity. What's the mechanical characteristics of our body tissues? Our body tissues are not pure elastic or plastic or fluid. So most of our body tissues are actually viscoelastic materials. It means that they have the property of elastic and viscose, both of them. So by application of stress or force, by stress I mean the force per area. So the application of force or stress may cause temporary deformation of the viscoelastic materials if we remove the force quickly. But if we maintain the force and stress for a longer duration of time, we may have permanent deformation. And how we can show whether a material is strong enough? Usually for showing the strength of a material, we use the graph of the stress strain. So what is the stress? Stress means the amount of force per area. So you can imagine that when we have a larger area, the force is applying to a larger area, we have less stress. Strain means the percentage of changes in length, and this percentage can then, this number can be positive or negative. Okay, so in the left side, the graph is related to tendon, for example. So you can see when by increasing the stress, the length, the percentage of change in tendon length is increasing until we're reaching to a point that the tendon, even with a little bit of stress, the change in length can happen. And in that stage, we may reach to the point that we have microscopic failure and small tear in the tendon. If we give a little bit rest and recovery time to tendon, we may have the healing and restoring of tendon function. But if we still have problem, I still have a repetitive type of movement, and still load is applying to the tendon, which is in that stage of strain, so we may reach to the point that that we can have macroscopic failure in tendon, and the tendon doesn't have enough strength after that. The same in the right side is for bone. You can see that the stress strain graph for the bone is sharper, much sharper than the tendon, because bone are more brittle and they are stronger. So this sharp curve shows that the brutality of the bone is much higher than tendon. So it's still, again, you have by increasing stress, you have small changes in the length of the tissue, until you reach to the yield point. And in yield point, you can have the changes in the length of the tissue by even smaller stress amount, until you reach to the ultimate strength, which is the final, the max that tissue can tolerate. And after that, you have the fracture, or stress fracture, which is very common injuries, especially in sports, a common sports injuries, and it's a type of cumulative type of injury. If you want to understand the work-related injuries, you need to understand the healing process as well, or the physiology of healing. For example, this graph shows you the tendon healing process. As you can see, tendon healing is very time-consuming, and there are different stages. At the first stage, or at the first phase, we have inflammation, and so we have pain, we have swelling and discomfort. The treatment objective in this stage is to somehow control the inflammation and the patient's pain. So after that, we have a proliferation phase, that we have a lot of cells in the injured side, and these cells can produce collagen. But the collagens that are produced in this stage are not strong enough. So we need another stage, another phase of consolidation or remodeling phase, that this collagen can be aligned and they can make bridges and connect to each other, and make a frame that are strong, that can be strong enough to tolerate the load and force. So this consolidation phase takes a few months, and for this phase we may need a little bit of loading, but this loading should be appropriate, because if we have overloading, we may somehow deteriorate this remodeling phase. So imagine that during the early remodeling phase, or in the proliferation phase, a worker is returned to work, and he's doing a repetitive type of movement, or he's doing the movement that can somehow cause inflammation and irritation. So it's what's happening, that we actually don't let that the tissue be healed enough, so we have the cumulative type of injury in that stage. You should notice that for both acute and chronic injuries, the direction of force application is important too. So for example, you know about the tension, compression, torsion, bending, shearing. So each type of force application may cause a specific type of deformation, and also a specific type of injury. Now that you know about the different mechanical properties of the materials and the force directions, so let's look at the intervertebral disc. You know that intervertebral disc is actually a cushiony type of materials that is located between two vertebrae to somehow control the friction between the bones. Intervertebral disc has three parts. In the middle part, it's which we'll call it nucleus pulposus, is actually like a small ball which is filled with colloid gel. And 77% of the material of this jelly is water. Around that nucleus part, there is a fibrocartilaginous ring which form the exterior part of the disc, and we call it annulus fibrosus. We also have two cartilaginous end plates in the two sides of the disc which are connected or attached to the bones. So you can see that during standing there is a force which is a compressive force which is applied to the intervertebral disc by the body weight and by the gravity. When a person is in a standing position or posture, this compressive force is evenly distributed inside the nucleus pulposus. And we have a compressive force in the nucleus, but a tensile force which is again normally distributed in the annulus fibrosus. When somebody bends forward, the nucleus pulposus deforms, but in the direction opposite to the motion. When we have torsional stresses, again the annulus fibrosus may in part be under the tensile pressure, and the other side may be in the compressive pressure. And you can see, you remember that the stress is the force over the area, and when we have the force in a smaller area, we have more stress in that area. So our spine is more vulnerable to torsional rotation or movement. During the standing, this facet joint in our vertebrae can somehow control the torsional movement, but when a person is bending forward, this the effect of facet joints is less prominent than before. It's interesting to know that most injuries in back area caused by a combination of rotation and forward bending. So if we have a micro tear in annulus pulposus, for example, so you can imagine that if we don't give enough time for repairing, and we have the awkward posture for a long time, or a repetition of movement or awkward movements, we may predispose the area the area of annulus fibrosus to a complete failure, and that is when we have a different type of discopathies. For a long period of time, the researchers tried to understand the effect of body posture on intervertebral disc pressure and how the compressive force can be distributed in the disc. For example, you can see that in standing position, the pressure inside the disc is much lower than the pressure inside the disc when the person is in a sitting position. So you can easily understand that why the people who have a sitting job and they should sit for a long period of time are more predisposed to some kind of chronic back pain. I don't want to go through the details of the importance of basic science in occupational ergonomics, but I want to emphasize that for occupational ergonomics to develop as a discipline, we should have a broad set of general information, general understanding about the basic science, biomechanics, kinesiology, anthropometry, and the other fields. But at the same time, we need to have a good understanding how to translate this basic science information into the industry. I mean, how we can apply those information in industry. So in the recent decades, there have been a lot of attempts to develop the guidelines and use the basic science for enriching these guidelines. I try to introduce you some of these guidelines in our future classes. These guidelines have derived from the fact that most of abdominal MSTs can be prevented. We just need to evaluate the risk factors, the ergonomic risk factors, and also we need to design the workplaces in a way that the strain on the human body can be lessened. I'm sure that you know about the different type of prevention. In primary prevention, we actually want that to prevent the problem occurrence. For example, in medicine, vaccination is a type of primary prevention. In secondary prevention, a problem or an injury exists, but it's a kind of mild injury and the patient may have mild symptoms. We want to recognize the problem in their early stages and to prevent the aggravation of the problems. In the tertiary prevention, there is a problem, a severe problem, and we want to somehow adjust the situation and help the person to return to their normal lives or their normal work condition as much as possible. So we want to increase the functionality of the people who are already suffering from a kind of injury or problem. Most of the occupational medicine was actually connected to the tertiary type of prevention. It means that we could recognize, or we had some patients or some workers that they had severe injuries, and we helped them to rehabilitate and return to their normal lives, or somehow adjust the workplaces with their new condition. But little by little, the perspective of ergonomics is going to the other part of the prevention. For example, reactive ergonomics is when there is a mild injury and we can somehow, by different modalities, with different interventions, we can recognize the mild problem in their early stages, and then we can do intervention by changing the workplaces, by removing or modifying the risk factors, and so help the problem to be resolved, or we prevent the worsening of the problems. But the attempt is that we go to the primary prevention. Proactive ergonomics actually aims to stop the problem before it starts. So it is not a kind of reaction to the situation that or the problem that we have in workplaces, but it's a kind of prediction of the problem that may happen, an estimation of the problem that there is a potential, and control those things by a better design, by building a better work environment, and then control the occurrence of those problems. So we may have a kind of investment at the beginning of a proactive type of ergonomics, but the end result of this proactive ergonomics can be less expenses for the injuries and the sick leaves. Nowadays, 3D modeling systems can help us to somehow predict the risk of injuries in different workplaces. They are more common, especially in automobile industries. And you can see that by these models, which are based on our understanding of physiology, biomechanics, kinesiology, and etc., we can simulate a work condition and evaluate the stress amount and the stress level on different body parts, and to see whether those postures or those type of activities can somehow be harmful for the human body. One of the methods for primary prevention is job analysis and hazard assessment. So usually the ergonomists used to have to fill out different checklists and evaluate all the risk factors in workplaces. These risk factors can be environmental risk factors or work-related risk factors or even sometimes personal risk factors. The ergonomist should evaluate the risk. First, they should identify the risk factors, evaluate the severity of the risk factors, and recognize which risk factors are modifiable. And then they need to suggest some solutions for somehow modifying those risk factors. Understanding of the environmental risk factors and solving the problems related to environmental risk factors is actually a specialty, it's not a specialty in ergonomics. We have environmental ergonomics. Unfortunately, I don't have enough time to elaborate environmental ergonomics in this course, but just I want to mention that an ergonomist should evaluate all the environmental risk factors, and these environmental factors can be physical hazard, chemical hazard, or biological hazard. I saw this graph in one of the articles in Ergonomics which has been recently published, and I liked it. It's a kind of public health approach to prevent illnesses. They use the same approach for occupational injury prevention. So the first step is to improve data system and identify the work-related illnesses. Then we need a lot of research on risk factors and also the epidemiological studies and experimental studies to evaluate the nature of the work-related injuries. In the next step, we need to study the intervention options and how we can modify the risk factors. What are the solutions for the to improve the predisposing factors for work-related injuries? And then we have the implementation of those solutions and the organizational and management issues, and at the end we have the evaluation. It's a kind of reactive ergonomics, but I think it's working pretty well. After talking about different aspects of occupational ergonomics, you may ask whether really all these interventions work. So we need to look at the data again, and you can see, for example, from this graph that how the ergonomic interventions could decrease the total cases from 1976 to 2012, as well as the days away from work. Okay, then let me give you a summary of what we talked about till now. I wanted to introduce you the concept of occupational ergonomics, and I want to emphasize that occupational ergonomics is not only about human well-being, but also about improvement and optimizing the performance in overall system. We understood that most injuries in workplaces are the WMSDs, and the chronic type of WMSDs are very costly, and they can also affect the productivity. Interestingly, most of WMSDs are preventable just by modifying the risk factors and by better design in workplaces. And it's interesting that you remember that a proactive approach in occupational ergonomics is much better than the other approaches. And in this approach, we want to stop problem before it starts. Thank you very much for your attention. And if you have any question, you can send me an email or we can arrange an appointment. I usually put some sample questions at the end of each presentation, or even when we have some reading materials, I may upload some sample questions for you. Then you can understand which type of questions you will have during your midterm exam or final exams, and which topics are more important for me. Let's start with question 1. Which sentence can better define ergonomics? And you are right, number 4 is correct, because it considers both aspects of ergonomics, which is optimizing human well-being and optimizing the system performance. Question 2. Which part of the body is more commonly affected by work-related injuries? And from the data that I showed you, you know that number 2 is correct, and most of the injuries are located in the spine and back area. Okay, question 3. Which of the following scenarios is related to cognitive ergonomics? And you can see all of the work situation can be an example of cognitive ergonomics, because all these jobs need a lot of cognitive abilities, and also the person may be under different psychological stresses. Question 4. Which one is not the cause of a cumulative injury? And you can see number 2, slipping or tripping, can cause acute type of injuries, while repetitive motion, vibration, and awkward posture can be the cause of different type of chronic injuries. And finally, question 5. An ergonomist recognized the cause of muscle fatigue in a group of workers and improved the condition. Which type of prevention is it? And you can see that there was a problem, a mild problem, such as muscle fatigue. The ergonomist recognized the problem and solved the risk factors, so it's a secondary prevention. Thank you very much for your attention, and I hope this lecture was useful for you.